Welcome! Today we'll be going through question 1 from the International Math Olympiad 1986. Let D be any positive integer not equal to 2, 5 or 13. Show that one can find distinct A and B in the set 2, 5, 13 and D such that AB minus 1 is not a perfect square. Please pause the video here and have a think about the problem on your own before proceeding to the hints and solutions. Hint number 1. How could you tell if a number is square? Hint number 2. How can you use modular arithmetic to determine if a number is a square or not a square? Hint number 3. What are the possible remainders when a square is divided by 4? How can you use modular arithmetic to help you with this? What about the possible remainders when a square is divided by 16? Solution. So we will consider D in modulo 4. Now the quadratic residues of modulo 4 are 0 and 1, because 0 squared is 0, 1 squared is 1, 2 squared is 4, or 0 because we're in modulo 4, and 3 squared is 9, or 1. So this means that when a square is divided by 4, it leaves remainders 0 or 1. Now, if D is 0 modulo 4, then 2D minus 1 is 0 minus 1, which is minus 1 modulo 4, which is not a square, because minus 1 is not 0 or 1. Now, if D is 2 modulo 4, then 2D minus 1 is 4 minus 1, which is 3 modulo 4. Again, this is not a square, because 3 is not a quadratic residue of modulo 4. Now, if D is 3 modulo 4, then 5D minus 1 is 15 minus 1, which is 14, or 2 modulo 4. Again, this is not a square. But when D is 1 modulo 4, things are not so simple, and we have to move into modulo 16. If D is 1 modulo 4, then D is either 1, 5, 9, or 13 modulo 16. Now, as previously, the quadratic residues of modulo 16 are 0, 1, 4, and 9. So when a square is divided by 16, it must leave remainders 0, 1, 4, and 9. If a number leaves another remainder when divided by 16, it's not a square. Now, if D is 1 modulo 16, then 13D minus 1 is 13 minus 1, which is 12 modulo 16. So not a square. If D is 5 modulo 16, then 5D minus 1 is 25 minus 1, which is 24, or 8 modulo 16. Again, not a square. If D is 9 modulo 16, then 5D minus 1 is 45 minus 1, which is 44, or 12 modulo 16. And if D is 13 modulo 16, then 13D minus 1 is 169 minus 1, which is 168, or 8 modulo 16, again not a square. So we have shown that whatever D is, we can always find such A and B where AB minus 1 is not a square, which was what we needed to prove, and hence the solution is complete. Thank you for watching this video. I hope you enjoyed it. Feel free to drop a comment in the comments down below, and see you next time. Goodbye.